Okay, we're back and I'm on example number 8. Just to remind us of our lipit, logs, inverse trig, polynomials, exponentials, and trig. That's what we would make our u, okay? That helps us decide what to make your u. So, this first one is the integration of x squared cosine x dx. So polynomials come before trig for our u. So our polynomial is going to be our u. Our du is 2x dx. That leaves cosine x dx. Because remember, this has to be the integral of u, and then this would be our whole thing left would be our dv. And then you're imagining that you're integrating both sides. Sorry, I don't know what I just did there, but if I'm integrating both sides, what can I take the derivative of that will give me cosine? That would be sine. And so now I've got our answer to be u times v. So I've got x squared times the sine of x minus the integral of v du. So I've got 2x sine x dx. I kind of just took this times this, and I put the 2x in front. Oops, I forgot my x on sine. So now we're going to have to use integration by parts again. So here's the box for our second one. We're going to again choose our polynomial to be our u, and then when we take the derivative, we get 2 dx. That leaves us with sine x dx for our dv on this integral. And imagine that you're integrating both sides, and what can I take the derivative of that will give me sine? That would be negative cosine. And so now I've got x squared times the sine of x minus, now put a bracket here because this integration is going to be the u times v minus the integral of v du. So we want to make sure that this negative gets distributed. So u times v is going to be negative 2x cosine x, because I just took, basically that times that, minus the integral of v du. And so this will be negative 2 cosine x dx. And again, I'm putting it in the way I want to see it, So we've got x squared sine x. I'm going to distribute the negative, so plus 2x cosine x. And then here, I've got a negative here and a negative here. That's a positive, but then I've got this outside negative, so that's going to be negative. I'm going to bring the 2 out in front of the integral of cosine x dx. And so this last integral, we don't need to do integration by parts. We know that we can solve that by just saying, what can I take the derivative of that will give me cosine? That is sine. And then add our plus c because it is an indefinite integral. And that's our answer. So sometimes you have to use integration by parts more than once. When you have to do that, most of the time there is something called the tabular method. And it works well when you have a polynomial and another function that that kind of has a pattern like sine or cosine. Those two have a pattern that repeats. So it works the best on those types of functions. And what I was going to do is I was going to show you how I could get this same answer using this tabular method for this original. And I was going to just put it kind of over to the side. Okay, so I'm going to show you how that works. What you do is, whatever you're going to make your u, you go ahead and start with that. So again, I'm using this example number 8 before I do example number 9. I'm just kind of showing you what tabular method is. We decided that this was our u. Well, go ahead and just keep taking the derivative of that until you get to 0. Okay, so these are all of your u's, and you just went and you took the derivative, took the derivative, took the derivative. I want your dv's to go on this side. So for our first one, cosine x dx was our dv. And I'm just going to put cosine. And then I want you to integrate. So if you were taking the integral, what can I take the derivative of that would give me cosine? That would be sine. What can I take the derivative of that would give me sine? That would be negative cosine. What can I take the derivative of that will give me negative cosine? That would be negative sine. And you can stop there, okay, because you get to 0 at that point. So when you get to the across from the 0, you can stop. I'm going to change my color here, and I'm going to connect this top one to the second one to the third one to the fourth one, okay? And when you're doing that, I want you to remember that this gets multiplied by positive 1, this one gets multiplied by negative 1, this one gets multiplied by positive 1, and so on and so on. So if I take x squared times sine of x times positive 1, that gives me positive x squared sine x. If I take 2x times negative cosine times negative 1, I get positive 2x cosine x. And if I take 2 times negative sine x times positive 1, I get negative 2 sine x. And then I have the plus c. So you can see that we could get that same answer using tabular, and tabular does seem to be a lot quicker, okay? I'm going to have to stop the video.